So I would like to welcome again our guest speaker, Brad, for being here and for being here and his great participation with us. We would love to know more about you, Brad, your professional experience, your background. Over to you, Brad.
Sure. So thank you so much for having me, and thank you for the introduction. So hi, I'm Brad. I'm currently, as you said, an engineer at Google, working mostly in machine learning and specifically in developing machine learning experiences for developers, and working a lot in just improving developer experiences in terms of the tools that we have, specifically in the realms of machine learning and some big data as well. So a lot of that involves teaching developers, providing documentation, and tutorials, going and speaking, and just really making sure that people who are using machine learning are getting the best experience that they can. And so a little bit to how I got here. So I've been working as an engineer for a little over 3 years at this point, and this has included traditional software engineering roles, data engineering roles, a bit of machine learning engineering as well. And I went to school for math and computer science. And now I'm at Google.
Great. Thank you so much, Brad, for such a lovely introduction. And so, Brad, here we'll start with the question and answer round, where we'll ask you a few questions on behalf of our attendees. And our attendees would love to know about the answers. Just give me a moment. I'll quickly start the question and answer round. Just a moment.
Absolutely.
Great. So, Brad, could you please tell me, how would you define machine learning to beginners?
Sure. So the way that I tend to describe it is that machine learning is the ability for computers to learn from data. So in traditional programming methods, if you want to have a computer, let's say, identify if a certain piece of data is, let's say, an integer or a string, we have a pretty easy way to do that given traditional programming methods in almost any programming language available today, or in fact, all of them. However, if you try and tell a computer to identify something as an apple, well, how would you program into a computer what an apple is? Do you say, is this thing? Let's say you provided an image of an apple. Do you say if it's red, then it's an apple? If it's round, if it's an apple? If it's weighs 8 ounces, it's an apple? These are things that are very difficult for a computer to actually learn in and of itself, and to create a decision tree to determine whether or not something would be, let's say, an apple, or even compared to, even if you're doing something simple like comparing it to an orange. The idea here is that that's very difficult to actually, if not impossible to do, by using a traditional decision tree and if statements or case statements. So we introduce this concept of machine learning, which is where we'll say to the computer, hey, this is a picture of an apple. This is also a picture of an apple. This is a picture of an orange. And we allow the computers to learn the patterns that are available in the data, in this case, in the pixel values of the actual image itself. And so that was really difficult to do before we had these techniques of just telling the computer to learn given this this labeled data. And there are, of course, techniques for dealing with unlabeled data here, but just to generalize here, I think that gives a fairly high-level overview of what machine learning is and why it might be useful.
Fantastic. It was a brilliant answer. So, Brad, can you please tell us the main areas or services where machine learning is used?
Sure. So in 2019, machine learning is absolutely everywhere. And I'll name a few. This is absolutely not an exhaustive list, but you have machine learning showing up in areas such as finance, in dealing with stock and high frequency traders. A lot of that has machine learning powering those decisions. You have machine learning in advertising, and decisions being made in terms of what or targeted advertising specifically uses a lot of machine learning. Computer vision is another huge field. Self-driving cars is, of course, a subfield of that, but that's powered a lot by the powers of machine learning. There's a lot of work also in dealing with text. So you have things such as sentiment analysis, which is determining if the text is, if this snippet of text is happy, sad, is the person saying this, or the context of the text angry. You also have this showing up in fraud detection, a few others, weather prediction. There's a lot of also AI being used in medicine, in robotics. That also ties into computer vision a lot. In video games, a lot of the AI agents that are being that are present in video games nowadays are powered by machine learning. You also have this showing up in, I was mentioning text before, so we also have speech to text. There's a lot of work being done in terms of being able to take audio and translate it into a translated text, as well as vice versa, to go from text to speech. We also have recommendation models. There's a lot of work being done there to have machine learning assist in determining when when one thing should be recommended to another, when they might be paired very closely together. And last but not least, also translation in and of itself. So going from one language to another, which honestly is one of my personal favorite use cases of this, because it just makes the ability for people to communicate so much easier if we're able to have text be translated accurately and efficiently.
Wow. Thank you so much for the answer, Brad. So here comes my next question. What skills should people have on their resume to stand out for machine learning positions?
Sure. So if we're specifically talking about machine learning engineers, I think that one thing to definitely think about is that just having the basic skill set of what a software engineer consists of is really important. So, the name says it itself. You are an engineer, and you do have to know, your data structures and algorithms and just how to build software in general. But specifically on the machine learning side, this definitely varies depending on the type of roles that you're interested in. So if you're interested in, let's say, learning, or if you're interested in a role that might be dealing with computer vision tasks, then you'll want to know about, convolutional neural networks and other techniques for actually doing computer vision. And if you want to work with, let's say, text data, then you should know about, recurrent neural networks and also convolutional neural networks in this case. Another thing too is that you definitely want to be familiar with a lot of the popular libraries and frameworks for doing machine learning. So one of the ways to do that would be to get started with something like, let's say, TensorFlow or PyTorch, and being able to show that you are proficient in that. It's definitely very good to have. There's other machine learning libraries as well. So I specifically have used a lot of Python, so I'm very familiar with the Python ecosystem. And if you want to get into machine learning also, I do recommend that you learn Python. You can do it with Java, you can do it with R, but I think that Python is definitely the most popular nowadays. And so if you're just interested in breaking into the field as quickly as possible, definitely having that experience building software in Python and then learning Python packages, as I mentioned, TensorFlow and PyTorch are two good options. Keras is another one, scikit-learn. And yeah, just having experience there. And the best way to really get that experience, if you're just new to the field, is really to either take a class. There's a tremendous amount of really solid machine learning courses online. Specifically, I highly recommend Andrew Ng's courses, machine learning and deep learning courses on Coursera.org. I think are really good to take a look at. But also build some small toy projects. It doesn't have to be anything that's it doesn't have to be anything novel. It can just be you reading, let's say, a scientific paper and just copying the model there, or even just working on one of these models in one of your classes and just being able to explain it and articulate what you did and why you did the things that you did, and being able to just talk a little bit about those on your resume. You don't want to go too far into it on the resume. You definitely want to save that for the interview itself. But just actually having that experience of going out and building models and just being able to articulate that a little bit on your resume will definitely help you stand out.
Wow, you were awesome, Brad. I'm sure if our attendees are going to imbibe what you said, they're definitely going to stand out. Lovely. So,
Awesome.
What is the career path of a machine learning engineer?
Sure. So the short answer is anything. There's a lot of different paths that you can go from being a machine learning engineer. So an obvious path would be to becoming a senior machine learning engineer, which is typically just acquired from either working in the same place for a while or just working as a machine learning engineer for a very long time, or not even a very long time. I mean, it could just be a couple of years to really just get that solid experience. But also, if you want to become a data scientist, there's a lot of overlap between what a machine learning engineer works on and a data scientist works on. If you want to become a machine learning researcher, there's a lot of opportunity there. And that could be just through industry or even going back to get an advanced degree if you don't already have one and are interested in doing so. You can also transition to being an engineer in really any other discipline if you want to work on, let's say, databases or data pipelines or even web backends or front ends. The sky's really the limit here. There's anything you could do anything that you want. But in terms of so those are all technical roles, but it also sets you up very well to move into non-technical or less technical roles, I should say, in terms of something like management or project management. Especially for a field like project management, there's a lot of value to be had if you have that technical know-how, but also have the I guess what I like to call the soft skills, or interested in gaining those soft skills to be able to take on a role like that. There really is a lot that you can do here. I don't think that, I mean, you don't have to be a machine learning engineer forever if you don't want to, but you also could, and it would be a really exciting and interesting career. I personally think that this discipline is here to stay for a while. I mean, so many companies are interested in learning or taking this stuff on in their enterprises. And while there are a lot doing it now, there are certainly a lot that aren't and are looking to and need people and to come in and build this stuff and will for a while. So yeah, so just to go back to I guess my original answer, the sky really is the limit here, and it'll allow you to it'll definitely open you up to a lot of opportunities depending on what your interests are. So I guess my best advice here is to try it, and then if you really like it, great. If you think you might be interested in something else, then go learn more about it. Just do a quick search online for how to become this thing, as just how to become this thing, or even how to become this thing from as being a machine learning engineer. And there's people on the internet talking all about this stuff.
Great. It seems to be a lot of, I would say, a lot of opportunities for a machine learning
Definitely.
engineer. Yeah, that's
Definitely.
lovely. So, could you please, tell us your views about the difference between the deep learning and machine learning?
Sure. So this is an excellent question. I love talking about this. So I think that the best way to describe this is that deep learning is a subset of machine learning. So when you look at something like machine learning, there are many, many, many different types of algorithms. And one of these algorithms specifically is the concept known as neural networks. And the name does come from what you would think it does, similar to how the neurons in your brain are interconnected with each other, which are also called neurons. But the idea here is that these neural networks allow you to scale out and allow you to create more complex models for more complex problems. And I think that one misconception about deep learning, and while deep learning is great, and I am personally a huge fan of it, I do think that it is very easy to take deep learning models and just throw them at everything. And by that I mean that any problem that if you're working on a new problem or you're trying to build a new model, your first thought might be to just throw a neural network at it, which does happen a lot. However, a lot of the more traditional machine learning methods, as they're called, such as something like logistic regression or k-means clustering, might be more than enough for your need. And while deep learning is great and can create very powerful models, they also tend to be very expensive computationally and can require a lot of resources to maintain and manage. And sometimes that's just not necessary. But that being said, they are the state of the art for a lot of problems, specifically in the realms of computer vision and many text problems nowadays. So they certainly are good to know, and again, are certainly the best solution for those sorts of problems. But I think one thing you just need to keep in mind is knowing when that is the case. And a lot of that just comes from trial and error, or talking with other people who may have worked on similar problems in the past, or just doing research online and seeing how it may have solved that problem.
Fantastic. So, Brad, do you think can machine learning be a part of AI?
So another very interesting question. I know that I've spoke to colleagues about this and other people that I've met just at meetups and conferences, and I think when we talk about artificial intelligence, I think the definition in and of itself is very vague, and I think the definition continuously changes. So the reason that I mentioned this is that if you look at something like, let's say if we go back 50 years, I don't remember exactly when the first chess algorithms were developed, but at the time, many people thought that that was considered artificial intelligence. Where nowadays, if we look at what those models were doing then, those were very basic, relatively speaking, and our current definition of artificial intelligence might not line up to what it was described back then. So my point here is I do think that you can make the case that machine learning is used heavily in terms of artificial intelligence, and a lot of tools that we are calling artificial intelligence today are powered by machine learning algorithms. But I would not say definitively that machine learning is completely, I would not say that machine learning is a complete subset of artificial intelligence. I do think that there is a world and a subsection of machine learning that you might not consider artificial intelligence, just given the nature and the relative simplicity of the algorithms. But I think this again does come back from the point where machine learning has more of a defined definition, or that I would say is less contentious than the definition of artificial intelligence in and of itself, which I think is why you'll have it, depending on your definition of AI, that the answer to this question may change a little bit. But also down the road, whatever the state of the art is for a lot of this artificial intelligence, it may not actually be machine learning. And then, then at that point, machine learning isn't a subset of AI because it's just not doing anything for AI anymore. So I think it's a little difficult to answer.
Great. The answer was also really interesting. So, Brad, what are the common questions asked in an interview for machine learning job?
So I think that this varies a lot based on someone's experience, but there are some things that I would say that anyone should know, whether you're a junior engineer or senior engineer. So just to list off a couple of common ones, I think a good one to know is the difference between supervised learning and unsupervised learning, and being able to explain when you might use a supervised learning algorithm versus an unsupervised learning algorithm. And just to give you a little bit of an understanding what those two are, I mentioned this earlier, or I started to mention this earlier a little bit, but supervised learning is the branch of machine learning that deals with training on data that is labeled. So for instance, I was using the Apple example earlier. So a supervised learning example might be learn that this is an apple, given that I'm telling you that it's an apple, so that when I in the future provide you with another picture that's not an apple, you will know that it's not an apple. And then unsupervised learning is training on data that is actually not labeled altogether. And that a lot of times comes in the form of clustering algorithms. But that's definitely something to know. And I think I'll leave it to all y'all in the audience to, I guess, take that up for yourself. A couple other things that I think show up a lot are in terms of case studies. So given that let's say you might be asked I want to build something that does, I want to build an algorithm that can detect the difference between an apple, or I want to build a model that can tell the difference between an apple and an orange. So what might be some algorithms that you suggest doing? What are the trade-offs of doing that algorithm versus another algorithm? And just being able to explain and defend yourself, I think is really important. Another good question is model accuracy let's say, is model accuracy the best metric for testing model performance? And I think your answer to that question is very indicative. The correct answer is no. It absolutely does depend. And again, I'll leave it to y'all to go and look at that yourself and see if you can figure out why that is the case. Some other questions include what is the bias variance trade-off, and understanding what it means to have an overfit model versus an underfit model. Another one is, let's say there's two algorithms, machine learning algorithms out there called K nearest neighbors and K means clustering. And though they have similar sounding names, they're actually very different, but they are often confused. So knowing the difference between those two is important. Another question might be to derive a simple algorithm from scratch and explain the mathematics behind it. And just, in being a machine learning engineer, there is definitely some mathematics that you need to know, specifically linear algebra, some statistics, and some calculus. And a lot of that can be done, or a lot of that can be shown by being able to derive an algorithm. Yeah, I mean, there is a lot of overlap between what you might expect from a traditional data science interview as well as a traditional machine learning interview. As I mentioned earlier, you are an engineer and you still need to know about your data structures and algorithms, and you need to know the difference between, let's say breadth first search and depth first search of a binary search tree, and something like, or let's say graph algorithms and sorting algorithms and array algorithms. You still need to know all of that. So in that sense, it does make a machine learning engineer someone who really knows a lot of different things, which is cool from a learning standpoint, but also something that you need to make sure that you walk into the interview being able to answer, because all of that is fair game and all of that can come up on the job. So then just making sure that you're prepared is something that's really important going into the interview.
Wow, such an elaborative answer. Thank you so much. I'm sure, these questions which you told are really going to help our attendees in their interviews.
I hope so.
So, yeah, me too. So, the next question is, what are the best resources to prepare for machine learning engineer interview?
Sure. So I think one fairly straightforward way to do it is to just go online and look up, just do, let's say a search on Google for what are common questions for a machine learning interview. And I think there's no shortage of resources out there. To just name a couple specifically, for the software engineering part of the interview, I can recommend no better resource than Cracking the Coding Interview. It's about probably $25 on Amazon, and that has helped me out through numerous interviews, just in terms of the baselines of software engineering. So again, those the graph and tree algorithms and the search and sort algorithms, those sorts of things. Cracking the Coding Interview, it is written in Java, but that doesn't really matter that much, because you should be able to understand it and be able to translate it into any other language that you use. Really useful resource. In terms of the machine learning side of things, so I think really reading any book on, honestly, just statistics is really helpful, especially some Statistics 101, and just really making sure that you understand the basics there. There's some introductory linear algebra books out there that are really good. And I also recommend taking those courses such as Andrew Ng's machine learning, deep learning courses, because a lot of the questions that you may be asked will come from there. So I'd say those are probably my best bet. Another suggestion that really worked for me and helped me do really well in a lot of my interviews is to actually find someone who is currently working or has recently worked in the field and actually have them interview you, preferably on a whiteboard, because that is how a lot of interviews are done nowadays. There are some that are also done remotely, so either one works. But really, yeah, finding someone that has a track record for knowing what they're talking about and being able to ask you questions in a safe environment where they can help steer you in the right direction if you're, maybe perhaps just not answering correctly, or if they can provide more feedback to you in terms of how you answer the question. I think that is honestly the best way to do it, but I would not suggest starting with that. I would definitely suggest going through Cracking the Coding Interview and reading those linear algebra and statistics books before you move on to having someone interview you. But I do think that should be a really good, end goal before actually going to interviews.
Thank you for the answer, Brad. So again, on the machine learning subject, what do you think, what are the challenges associated with it?
Sure. So in terms of practical algorithms nowadays, there's actually no shortage of them. And I think a lot of the issues nowadays come in some of the skills surrounding the machine learning aspects, such as the data. There's a lot of issues nowadays in terms of data privacy, data fairness, and making sure that you have good and unbiased data. A lot of the catch-all about machine learning models is that they really are only, at the end of the day, you can have a brilliant model, but they're only the model's only going to be as good as the data that is trained on. So you need to make sure that you don't have bias in your data, and that you are accurately representing what you're trying to have the model accomplish. And so there's no shortage of issues of this out there. I remember a couple of years ago on Twitter, I can't remember the year. I think it was maybe 2015. Twitter released a bot that would simply start tweeting based on the interactions that it had with people on Twitter. And very quickly, the bot actually turned very racist and was, or I should say that the output of the bot was very racist and obviously not okay and not something that we want running around on Twitter. So Twitter had to take it down, but the idea was the data that it was trained on was not clean enough to be able to, or I guess maybe not that the data wasn't clean enough, but they weren't necessarily expecting this to be the case. And there's very few scenarios where you would want something like that to happen. So you just need to make sure that that the models you're creating are safe, that they're not harmful, that they're not misrepresenting certain groups of people or overrepresenting other groups of people. And I think that that's not an easy problem. And I think that there are academic researchers out there who are spending 100% of their time just on those problems, not necessarily on improving the models, but just making sure that there's ways to, well, I guess you could argue that is a way to improve the model. But yeah, like I said, a lot of it really does come from the data. And also in terms of model explainability. So if, as these models and then machine learning in and of itself is becoming more prevalent in society. I mean, it already is, but it's only becoming more and more widespread. The idea is, let's say that a model like this robot or this bot that was on Twitter that was making the racist remarks. Let's say that ends up. Let's say there's a court case on that, and let's say Twitter gets a peanut in terms of like asking, why did this model do this? Like, why did you have a racist robot running around on the internet? And the ability to actually explain what the model was doing is very important in that case. And in a lot of instances, that's very hard to do, especially in the realm of deep learning. If you actually were to dive into many of these models, it just looks like a bunch of numbers, and which means absolutely nothing to any human observer, but to the model, it makes perfect sense, which is what we would expect. But it's very hard to actually explain to someone why the model made the choices that it made at a low level. It's easy to do at a high level, but not at a low level. And I think that that's going to become very important in the future. I also think on a little, I don't want to, yeah, I guess on a little bit more of a technical side, there is the issue of model hosting. So in the realm of machine learning and being a machine learning engineer, I think one common misconception about being a machine learning engineer is that you are building models all day. You are not. And that, depending on the role, can range anywhere from 5% of your work to, let's say, 40% of your work. A lot of the work actually comes from just being able to host that model and clean the data and build the pipeline for the actual machine learning system. Because let's say you wanted to create let's say we wanted to create a phone app that could take a picture of something and determine whether it was that takes a picture of an apple and determine, or takes a picture of a fruit. It tries to determine what type of fruit it is. Is it an apple, a banana, an orange? A lot of the work involved in that actually doesn't come from the model, but actually setting up the infrastructure for the app and being able to, let's say we're doing this on an iPhone, being able to actually write the app itself and having the proper front end and making sure that it interacts correctly with the operating system and being able to use the internal camera API and also being able to run the model itself on the device, which nowadays there are a lot of a lot of libraries out there to do that, specifically things like CoreML and TensorFlow Lite. But a lot of the work just surrounding hosting the model and getting the model into an application where it's useful is very tricky. But I think that there's that's I went pretty deep into those, but I do think that a lot of the model related things in terms of just the accuracy of these models is looking pretty well. And as I mentioned before, deep learning is the state of the art on a lot of different cases. And a lot of these models are operating at near human or superior levels, which is really exciting, which allows, you might feel more comfortable removing the human from the from the loop in a lot of these cases, but you still need some oversight. And yeah, there's a lot of cool things going on, but there's definitely a lot of continued work that will not be solved in anytime soon, and just will continue to need more work.
Wow, Brad, what you were just awesome. Such, I would say, wonderful answers and so much knowledge. We are loving it. Great.
Awesome.
So, Brad, we are very keen to know about, your most interesting project of machine learning that you have undertaken till now.
Sure. So I think that the most interesting to me, this might not be super helpful, but I'll mention this anyway, and then I'll mention a more, I guess, technical one, is actually in terms of teaching people machine learning, which is a lot of what I'm doing now, and just being able to figure out how to get more people interested in the subject. I should say there are a lot of people interested, but just in terms of how to get people more interested and how to get the outreach out there, and maybe even some of the answers to these questions out to more people. So doing things like this webinar, are really awesome to me and are very helpful for both my mission and also in getting other people really interested and excited in working in the field. But in terms of more traditional algorithmic building, things of that nature, I would definitely say a project that I once worked on that dealt with summarizing large bodies of text into smaller bodies of text, and being able to parse the document or the various amounts of strings that were available, and providing just a more succinct summarization. If I was reading an article about, let's say, it's one of the presidential candidates, or someone announced that they're running for president in the United States. That's, most of those articles are, hundreds of, if not thousands of characters long, but at the end of the day, you may just care, oh, such and such is now a presidential candidate for 2020. And so building an algorithm that can read all that and then just determine that is the summarization, just as I might say, if someone asked me, what is the summary of this article? That was a lot of fun. And that used a lot of deep learning techniques, and just training a model to do that was definitely very challenging. And at the time, something I had not worked a whole lot on. So that was really cool. And I thought that was really fun.
Wow, that was really interesting. So what education background or experience, or I would say any certification related to course, is needed to get started in this machine learning field?
Sure. So so this is a great question. I do think that, there's a couple ways to approach going about getting started in getting a job in machine learning. So one way to do it is to go to school, get a master's degree, get a PhD, and you'll definitely be able to get a job that way. From what I've seen, there are still a lot of companies that do require PhDs, if not masters, to break into the field. But I do think that there are a lot that are moving away, especially as access to knowledge in the machine learning realm is becoming so much more accessible. I personally don't think that you need that higher level to be able to really provide value to an organization. I do think that a lot of these online classes, and people have completely different opinions on this, but I do think that these online classes are providing a lot of real value in terms of getting people just up and running with the basics. You will still have to build some of these models on your own time and work on some projects to really be able to understand how to build this stuff. Because at the end of the day, the best way to really get started on anything. And I actually meant to add this earlier in terms of things that you should do, but the only way to learn anything, in my opinion, is just to do it. So you just need to be building models, and you just need to be reading, let's say, research papers and taking these classes. And sure, you can do that in an advanced, in an academic setting, such as a graduate degree, a master's degree, a PhD degree. But at the end of the day, all of this stuff is freely available to you. So you don't need to, you don't need permission to just go on archive, which is where archive.org is where machine learning research is most machine learning research is published. That is completely free, and you don't need anyone's permission to just go and start reading this stuff. And if you have any questions about these things, you can often reach out to the author of the paper. You can post on any online forum and say, so I know Reddit has a subreddit for research papers. And if you have any questions, people are more than happy to help. So you definitely don't need that advanced degree. It doesn't hurt, but you also have the trade-off of, do I want to spend all this time at graduate school versus just getting into the field and teaching this stuff on my own, or even on this, after hours, if you're not working in machine learning currently. So I'll speak specifically to someone who is, let's say, a traditional software engineer, or I shouldn't say traditional, but someone like who's an engineer that's not in machine learning, and they're interested in learning about machine learning. Then you can learn it after work, or you can see if you have colleagues at your company that are working on this stuff already, and you might be interested in learning a bit more about how to get into it. Just talk to them and pick their brain and work on these models, after hours, and then ask them if they can help you out. With anything in terms of otherwise, so outside of, let's say, getting an advanced degree, I can't think of any certification off of the top of my head. I mean, these Coursera courses do technically give you a certification. I don't know that having that certification in and of itself means much to a lot of employers. That's where I'm not entirely sure. I think it's more just whether or not you have the know-how and are able to show it either in an interview or just in projects that you worked on, that you're doing interesting things. And just I think that you can go get an advanced degree, but I don't think you necessarily need to. I think the most important thing is that you just start building models. Do it on the side. For what it's worth, I don't have an advanced degree. I only have a 4-year degree from a university in the United States. And I'm working in the field. So I think having an undergraduate degree as a minimum would probably help, especially and that's for many reasons, but I know that there are a lot of engineers out there who don't necessarily have degrees and just self-taught themselves programming and machine learning and all these sorts of things that you need, and got them a job.
Great. So, Brad, what do you think? What are which are the best companies to work for aspiring ML engineers?
Sure. So, I don't think there's necessarily like objectively best companies. I think there are a lot of great companies out there that are doing work in machine learning, such as the OpenAIs and the Googles and the Facebooks of the world are of course hiring lots of researchers and doing a lot of work in that sense. But I don't necessarily think that the end all be all is to necessarily work at one of these, larger tech companies. I think that there are lots of great companies out there that are doing awesome machine learning work, a lot of startups, a lot of research labs, and there's just no shortage. I think what I would like to comment on are things that you should look for when you're looking at for a company to potentially come on board with as a machine learning engineer. I think some questions that you should ask are like, what are some of the problems that you're working on? I think it's also good for you to identify some of the problems that you want to work on. So for instance, if you want to, let's say, be computer vision, you want to work in computer vision, then you should look for a company that has those sorts of problems. Or if you want to be working on text data or financial data or recommendation systems, there are a lot of companies and a lot of really interesting startups that are doing this sort of work. And I think it's good to really have an idea of the sort of things that you want to be working on, and then do your due diligence and do some research and see what these companies are and where I can find them and how I can potentially just get in front of someone and be able to pitch yourself and hopefully get an interview and just take it from there. But I also think it is good to just in the event that you do get there, I think it's good to just ask, like I mentioned earlier, what are the problems you're working on? What sort of data do you have? Do you have the necessary infrastructure to actually begin working on machine learning problems? And I think that there are a lot of companies out there who are a little bit ahead of themselves in terms of saying, okay, I don't currently do a lot of work in data science, but I want to. But you also need to have the appropriate infrastructure and have data engineers working on those pipelines and having those data warehouses set up for you so that you can actually access this data and begin to make better utilization of it. So I think it's just really good to get a picture of what you'll actually be working on before you make the plunge into a new company. But to answer the original question, I don't like to say that there are best companies. I think it sort of depends on anything that you're interested in working on.
Thank you so much for the lovely answer, Brad. What do you think, what job search strategy would you recommend to land job in machine learning?
Sure. So I'll start off by saying the one thing that I don't recommend doing is cold applying it to companies on job listings. I think that it's very difficult. So statistically speaking, it's actually very unlikely that if you send out a bunch of resumes to people that some of them just won't even be seen. Objectively, there's just some companies receive so many applications that it can be very difficult for the hiring managers to even read through all of them. So the odds are just against you. And there are cases of people who have been hired through these job listings. I know people that have applied and have gotten very lucky and have gotten responses. But truthfully, I think the best answer, the best way to get a job is through a referral. Whether it's someone you know, a family member, a friend of a friend, a friend of a friend of a friend, it's like whoever you know who can just submit you a referral, who can talk to you for a little bit and just give you an idea of what you're working on. That's really the best way to do it. And if you don't necessarily know anyone, then I think a great way to do that is to go meet people, go to meetups, reach out to people on LinkedIn and say, hey, I'm potentially interested in the field. I saw you have an awesome background. Would you mind if I asked you just a couple questions? Don't send them the questions. Just ask them if they could, if they wouldn't mind answering some of your questions, because then it allows them to say, you know what, like, sure, go ahead. Or, I don't really have the time. I apologize. But yeah, definitely meet people. A common phrase that we hear is it's who you know. And I couldn't agree more. And, a lot of the positions that I've landed have just been through meeting people at conferences, at meetups. Most meetups are free. If you're working, if you happen to live in a big city and there's a machine learning community there, just go to meetups and just, introduce yourself and talk to people. A lot of people at these meetups are there to meet people too. So, never feel pressured to just go up and talk to someone. And if that person's not interested in talking, that's fine. There's tons of other people there. So I think that, yeah, just going out and meeting people and networking is really important. I also think that having an online presence helps a lot. So if you are working on these projects and completing these different courses, start a blog, start a website, tweet about it, be someone who is sharing useful content on Twitter, or create your LinkedIn and, put all this stuff on your LinkedIn. I also do feel that if you start to build out your LinkedIn presence, that you will get reached out to by recruiters, especially if you're living in a big city. And that's definitely one way to do it, and just get on the phone with these recruiters and learn a bit more about the sort of projects that they're working on and anything that they can refer to you. But again, I do feel that just cold sending out of a resume is a very low likelihood of actually getting a position, because it might seem like this is it's really awesome for you to be able to send that out, but it's, at the end of the day, it's just another resume unfortunately to a lot of hiring managers. So you would I would definitely say try to avoid doing that and spend your time instead going to meetups and working on your online presence and attempting to land a job that way.
Great. Thank you so much. I'm sure it's really helpful what all you told. So such lovely strategies, and I'm sure all of the attendees are really going to follow the same. So my last question comes, Brad. What advice would you give an applicant seeking a career in machine learning to be successful in their career?
Sure. Two things specifically. So the first, which I talked about a little bit in the previous question, is to network. You just always want to be expanding your network, going to those meetups, reaching out to people on LinkedIn, reaching out to people on Twitter, and just having conversations. It's really, really important. And even if you're someone who has a job that you like and you're not necessarily interested in looking for a job now, that may change in the future. Your job might be great, but you might get a new manager or a new project that you don't like and you want to change. And you remember that you met that person at that meetup a year ago that you had a great conversation with. And it could never hurt to just reach out and say, hey, potentially looking to be on the job market if, maybe you know anyone who might be hiring. But also, even if you just have questions and you're interested in having educational conversations with people on terms of like the projects you're working on and the projects they're working on, and if there might be a way that you could help each other, just in terms of like, oh, you're working on this project, I did something like that recently, and like, here's some advice I might have for you. So networking is super, super important. And no matter what stage you're at in your career, that I think is always one of the most important things you can be doing. And then the second thing is also to continue learning. And that's not specifically for a machine learning engineer. I think this is for most fields, but specifically for engineering in general. The field is changing constantly. You know, Python is a hot language this year. Next year, no one might be using Python. I think that's very unlikely, but it's not impossible. You know, like there's always the flavor of the month, the hype, the thing that's really hyped. And you always want to be in the know, and you always want to know about new technologies and new packages and new updates to some of your you know, some of your favorite programming languages, and you just want to make sure that you're on top of that and learning about these new things and keeping, you know, go on TechCrunch and read things about what's happening in, you know, in the startup world, and go on Stack Overflow or other websites and just sort of see what people are talking about, and, you know, look at GitHub repositories and look at the work that people are doing. I think that's really important, and I think that that's what a lot of engineering is about, is just being on top of what you know and just continuously learning and reading different books and looking at different articles and talking to people. Yeah, so I would say definitely do that. And then of course with the learning, you know, build side projects and whatnot, but just making sure that you're always aware of what's going on in the tech world, I think is very important.